All right. So if you're going from decimal form to fraction form, the steps for that is the box on the left. So if you're looking at a decimal and there's anything to the left of it, that means you have a whole number. That part stays to the left in fraction form. If that is the case, that means you will have a mixed number. It means you have more than one whole thing. Then digits to the right of your decimal point would be put into the numerator of your fraction, which is the top part. And then the place value of your last digit when you're looking at your decimal tells you what your denominator should be. If you're unsure of place value, I give you a partial place value chart down here at the bottom to look at. Obviously, this goes on forever this way and to the right, but here's your decimal. If you're one digit away from the decimal point, that's the tenths place. 2 spots away is hundredths, and then thousands, 10,000s, 100,000. It goes out from there. So if you're familiar with the whole numbers, then the decimal place values are pretty much the same. They work their way out from the decimal point. The only thing that's different is there's no once place. There's just one. So this is kind of like your mirror, and then you work your way out. So once you've done that, then you simplify it to lowest terms. So let's do a few of these before we talk about going back the other way. So I'm going to quickly just jot them down. And then we'll work them out. Okay, where we go? There we go. Okay, so they're asking us to first take 0.3 and change that to fraction form. So repeating what I said before, anything to the left of your decimal are the whole numbers. You don't have anything, so you don't have any whole numbers for this. Digits to the right, in this case the 3, will go in the numerator of your fraction. And then the place value of whatever the last digit is tells you what your denominator is. So you have to know your place value to be able to do this. The place value in this, since it's one spot away from your decimal, is the tenths place. So here's my fraction, and then I would try to simplify this if I could, but there's nothing you can do to 3/10. So here's my answer. Okay, when you read it in decimal form, it'll read very similar in fraction form, at least before you simplify. So you would read this decimal as 3/10, and that's how you read this fraction too. So they should read the same before you simplify it. That's another check. Okay, the next one I've got here is 0.25. So we're going to take that to fraction form. Again, I don't have anything to the left to worry about, so I'm going to go right to the right here. And the 25 goes in my numerator. And then the place value of my last digit will tell me my denominator. So the 5 is in the hundredths place because you're 2 away from your decimal. Hundredths place goes down here then. As just a little heads up, when you're 2 places away, there's 1, 2, you need 2 zeros to determine the place value here. When you're 1 spot away, like up here, then you need 1 0 to determine the place value. Now we work for everything. Okay, so next, here's my fraction, but it's not done. So next I need to simplify this. And one of the easiest ways to simplify fractions is to just try to divide them both by the largest thing that you can. So since these are both divisible by 25, exactly, 25 divided by 25 is 1, and 100 divided by 25 is 4. So that one's done. Now, backing up just real quick. If you didn't happen to catch that 25 divides both of these, maybe you were thinking 5. You can still go with it. 25 divided by 5 is 5. 100 divided by 5 is 20. The issue is this is not done yet. If you want to do it, you need to divide these both again. The bottom line is, as long as you continue to go as far as it goes, you'll get the same answer whether you have to do it in several steps or just in one step. Okay, next one is 2.08. And they want that in fraction form as well. So now here you do have something to the left of your decimal. That means you're going to end up with a mixed number. So you leave the 2 off to the left, and then everything else is the same as far as the steps that you take. Numbers to the right go in the numerator, and the place value of your last digit is your denominator. So we're 2 to the right again. That means we're in the hundredths place. And this is what a mixed number looks like. It's got the whole number in front, and then whatever's left over, the fractional part, goes next to it. When you simplify, you only have to simplify your fraction. Leave the 2 alone. And then we got to think of something that we can divide both of these by. Does anybody know what's the biggest thing? All right, let's go with 4. So the 2, the whole number stays. 8 divided by 4 is 2. 100 divided by 4 is 25. And there's my answer. 2 and 2/25. This is mixed number form. You guys can't see that. Mixed number form is when you have a whole number in front. When you have a fraction where the numerator is less than the denominator, like this 1/4 here, this is called a proper fraction. And then there's something called an improper fraction. Improper fractions are when the top is bigger than the bottom, usually. And you can convert to improper fraction form from mixed number form by multiplying the denominator times the whole number and then adding the numerator. So you add here, then you multiply down here to convert. So this would look like 25 times 2, which is 50, plus 2 is 52. And the denominator stays. Yep. And these two things are equivalent, so you could give either answer and it would be fine. These are improper fractions when the top is bigger than the bottom. The top could also be equal, but that's very rare. Usually the top is bigger than the bottom. All right, any questions before I go the other way? We're going to go now from fraction form to decimal form.
No, I'm good.
Okay. So let's go back up here and let's look over on the right. All right, so now you're going to start with a fraction and convert it back the other way. And here are your steps. Any mixed numbers that you have, if you have them, you have to convert them to improper fractions, like I just showed you how to do. You go, just loop around, multiply, then add. Keep the denominator. Then you're going to divide. So we're going to set this up and do long division. You can divide it straight through on your calculator to check it as well. I'm going to show you how to do it by hand, at least to start. And then you just keep dividing until you see your decimal will either terminate, meaning it just ends, you have a 0 remainder, or it'll repeat, and then you'll see that pattern happen. If you don't see either one of those things happening, if it's just never seems to end, there's no pattern whatsoever, it's probably called an irrational fraction. It just means it's got no pattern and never ends, just like pi, for example. In that case, the directions will definitely tell you how to round. If you see rounding directions, chances are you're going to have a weird decimal coming out anyway. So keep it in mind if you see that happen. Certainly check it over with your calculator. Make sure you're getting the same thing in a case where it doesn't seem to be ever ending. All right, so let me jot down the first problem real quick. I am working now towards the bottom of this page. We're going to go 3/8 first. Let me see what that is. Oh, okay. All right, 3/8 to decimal form. There we go. All right, so I don't have mixed numbers here. I have a regular proper fraction. So that means I'm going to just start dividing. The numerator of anything you're ever doing, whether you're going to decimal form or doing anything else, the numerator always goes on the inside. Denominator's on the outside. Some people look at this when they set this up and think that they've done it wrong because you can't do 8 into 3. And that's the whole point. We're trying to make this a decimal, so we're going to bring that in. We're going to put it after the 3, and we're going to start adding zeros. You can add as many zeros to the right of a decimal as you want. This is $3. We talked about this the other day. $3 is the same thing as $3. You can put a decimal in zeros as much as you want. It doesn't change anything. All right, so once you've done that, now we can bring the decimal up and start dividing this. I'm going to go one by one, digit by digit, so it's not, hopefully it's a little bit less confusing. So since 8 will not go into 3, I'll stick the 0 up there and start all the way over here and look at this like it's 30. Once you place your decimal in your answer, you don't need to look at it anymore within the division. So it's going to be 8 into 30, which goes 3 times. 3 times 8 is 24. Subtract 30 minus 24 is 6. And then I'm going to bring down. And I'm going to keep going until I see it either give me a 0 for a remainder right here, or I'm going to hopefully see a pattern. So next, now it's 8 into 60, which goes 7 times, because 7 times 8 is 56. Subtract. 4 left. Not a 0 yet, so I'm going to add another one up here so that I can keep going. Now 8 into 40 goes 5 times. And 5 times 8 is 40. Now I got a 0 remainder. Now I can stop. Here's my answer. When I check it, just make sure when you plug this in that you plug it in top to bottom. So 3 divided by 8 in that order so that you can check it out. All right. Next one is, let's see, 2/3. All right, slide that over a little bit. Same thing, you are starting with a proper fraction, so we're going to go right to the division. 2 goes on the inside, 3 is on the outside. Add your decimal, bring it up, and you can add as many zeros as you need then to do this. 3 won't go into 2, so I'm going to put my 0 there so I can keep everything lined up. And then I'm going to look at this like 3 into 20. I'm going to ignore this decimal when I'm doing a division. 3 into 20 goes 6 times, because 6 times 3 is 18. And 20 minus 18 is 2. And then I'm going to bring down and do it again. Now I'm dividing 20 by 3 again, which the biggest amount is 6, which is 18. Subtract, and that's a 2. If I keep doing this, back to 20, what's going to happen?
Gonna repeat over and over.
It's going to repeat.
Exactly. So once I see it, I like to make sure that I see it twice before I stop, and I see 20 minus 18 and 20 minus 18. I know it's going to repeat. I stop. You can put a bar over whatever you see is repeating, as long as you put it only over what actually repeats. So there's a couple different things I want to talk about right now. If I put it over just 1/6, is that the same thing as putting it over this 6 down here like I just did for my answer up there? Are these equal? Anyone?
No, it's not the same.
Not the same? Let me see what everybody else thinks here. Yes, they are equal. So I have 1 vote for no and 1 vote for yes. What does everybody else think?
I would say no.
No, they're not the same. Yes, they are the same. So far, we got 2 votes for yes and 2 votes for no. Anyone else want to?
I don't think they are.
Okay. That's why we're having this conversation, because it's usually pretty split, 50-50. Like it is in this class too. All right, let's talk about it. Let's look at it. I'm gonna do it. Keep that up. I'm gonna do it over here. So let's talk about what the bar is trying to tell you. If you have a bar over one single 6 like that, what that means is that 1/6 is repeating literally forever. That'll go on forever. If I have a bar over this 6 over here, that means that I've got a 6 in the 10th place, and then a 6 repeats forever. So I got a 6 in the 10th place, and then a 6 is going to repeat. All right, so let's say it was something like this versus if you wrote the answer this way, which is how a lot of people write it. Are those two things the same?
Yeah, you took the 0.
Yeah, they're the same. It just means you don't have any whole numbers and then you have a fraction left over. This just means you have a fraction left over. It's the same thing. However, people who are going into medical related careers, you should be writing your answers this way. Everybody else, it really doesn't matter. It's just either way. Medical professionals write answers with the 0 in front to help with medication errors. So let me show you why. Let's say you're looking at somebody's chart and the doctor, who has extremely neat handwriting like they always do, has this written. And you don't see that little dot. They want you to do 25 milliliters of whatever it is. You don't see the little dot. You get 25 instead of 0.25. But let's say he did that.
And you killed him.
Yeah. If he did something like that, you're probably going to look twice and say, why is that 0 even there? And hopefully you'll see that little dot. That's why they do it. It doesn't eliminate problems, but it cuts down on some medication errors. And for the same reason, now let me add this onto the mix. If you put, so we know you're supposed to put the 0 in front for medical people. if you put zeros in the back of your answer, that's actually not recommended for the same reason. Instead of giving 0.25, maybe you give 250 instead. Zeros can be added on to the back of any decimal if you need them, but they should be taken off when you don't need them. So you want to leave it like that. Okay, now let me go back to the last question here. So 1 7/10. That changed to decimal form. Now you do have a whole number. We haven't looked at this yet. So anything to the left will stay to the left. And then we're going to divide. No, actually that's wrong. We're going to do it a different way. That's not what the paper says. So we're going to do it a different way. Paper told you to convert. So that's what we'll do. So 10 times 1 is 10. Plus 1 plus 7 is 17 over 10. Then we'll divide it. Numerator goes on the inside. Denominator on the outside. Since you can get this started, 10 does go into 17 one whole time. We'll put the 1 up top. 1 times 10 is 10. Subtract and we get a remainder of 7. So now, at this point, since I couldn't divide it evenly, now the decimal gets involved. You put the decimal behind, bring it up, and now you can start adding as many zeros as you need. And then continue your division. 10 will go into 70 7 times. 7 times 10 is 70, so we're done. And here's my final answer. Okay. Any questions? I'm about to move on to multiplying and dividing. Okay. Make sure everybody's still okay. I still got everybody here. All right, so that wraps up the first part. Let's go now to here. We're gonna talk about multiplying fractions separately. Then we'll talk about division. So when you're multiplying two fractions together, the rule is you just go straight across. Now this is going to take different forms depending on the type of fractions you start with, but as a general rule, you just take it straight across. If you have mixed numbers, like you have in this first problem, mixed numbers have to always be converted first to improper fraction form because you have to go straight across, and if there's a mixed number involved in there, it gets caught up in the mix. So you only want numerators and denominators. You won't want anything in front so that you can just take it straight and straight. So let's look at number 1. It's 2/3 times 2 2/5. All right, here we go. So the first step I have is I need to convert this. So I'm going to multiply. 5 times 2 is 10. Then add. 10 plus 2 is 12. Keep the denominator. My second step, I'm actually going to do this in 2 different ways. For the first way, I'm going to take it straight across the way I just mentioned before. So I'm going to do 2 times 12. And then 3 times 5. 2 times 12 is 24. 3 times 5 is 15. and then I need to simplify it. So I need something I can divide those both by, which in this case is 3. 24 divided by 3 is 8. 15 divided by 3 is 5. All right, so my answer is 8/5, which is improper, and it's fine. But what if they wanted this as a mixed number? We haven't talked about how you go back to a mixed number yet. We talked about how you go from a mixed number to improper, but not the other way around. So let's step aside real quick and talk about that. I want to go from an improper fraction to a mixed number, like this. I'm still going to divide it, just like I would if I were changing it to decimal form. My numerator goes on the inside, denominator goes on the out, then 5 goes into 8 one time. 1 times 5 is 5. Subtract, I get 3 left over. And what we just kind of finished talking about was you add your decimal, you add some zeros, you start bringing it down. That'll go to decimal form. If I want mixed number form, once I'm done, I have no other numbers left to bring down. This is all I need. The numbers that are in your answer become your whole number. So the 1 goes in front. Any remainder you have, if you have one, becomes the numerator. So in the mixed number, now it's the 3, and the 5 stays. The denominator stays. So 8/5 is the same thing as 1 3/5 in mixed number form. All right, any questions about any of that so far?
Dealing with these things is so weird. You can do so many different ways.
Yeah, I'm about to show you another thing because it's going to be needed to do number 2. I'm going to go back and I'm going to do this same problem, number 1, without going straight across first. I'm going to do something a little bit different. So if I have no questions, I'm going to erase all this and show you that second thing. We already know what it should be. I'm going to keep this over here. Just to show you that it'll work either way. We're still going to get the same answer. All right, the first step is never going to change. If you have mixed numbers, those must be converted. So this was 10 plus 2 is 12. All right, what is going to change though is I'm going to try to clean all of this up before I multiply it straight across. And that'll save me some work later on when I have to go to simplify. In a problem like this, going straight across is just as easy as what I'm going to show you right now. But in a more complicated problem, doing what I'm going to show you will save you a lot of time. So here's what I'm looking at. This 2/3. I'm going to try to simplify as much as I can before I multiply. So this 2/3, there's nothing I can do to simplify that. It doesn't go any smaller. Same thing with the 12 over 5. I can't reduce that. That's as far down as it goes. But what I can do is I can look at numbers that are diagonal.
Principal.
But I'm not going to multiply them together, which what some people try to do. I'm going to try to reduce them by dividing. I need something that will divide these both evenly, which is a 3. And what will happen is, I'm going to carry down the 2. Now 3 divided by 3 is 1.
1 and 4.
And this is a 4. Great. And then if I look at the other 2, there's nothing I can do to 2 and 5 to divide those down anymore. They have nothing in common. So this is all I could do, but now I'm going to take it straight across. So 2 times 4 is 8, and 1 times 5 is 5, which we got up there, and we don't have to reduce because we did it already. So let me try to sum this up. When you're multiplying, this is the only time you can do it. Can't do it with anything else. Can't do it when you divide or add or subtract. When you're multiplying fractions, you have 2 options. You multiply straight across, and then 5, or you simplify or multiply straight across. Same steps, just different order, and you're allowed to do it when you're multiplying because of the fact that 2 times 3 and 3 times 2 is the same thing. So if we mess around with this a little bit, it won't change anything when you multiply. Okay. Any questions? I'm about to do one that's a little bit more complicated to show you why I'm even showing you another way to do it. Okay. All right, so here's another one. It's 49 over 10 times 2 over 3 times 15 over 77. If I take this straight across, I'm going to have humongous numbers to deal with. So what I'm going to try to do instead is do a little bit of simplifying and then see what happens when I take it straight across. When you simplify diagonally, the rule is you just need one thing in the bottom and one thing in the top. It doesn't matter if you try to simplify the 10 with the 15 or the 10 with the 2. If you can divide these both by something that works, that's all that matters.
So you can do the 10 and the 15 by the 5 and make it 2 and 1.
Yep. So,
You can do the 49 and the 77 by 7 and make it
exactly.
7 and 11.
You could go a lot of different ways with some of these. Yeah, so I'm gonna go with, just to show, I'm gonna do the 10 and the 2 real quick. They're both divisible by 2. And I'm gonna start replacing stuff down here. All right, so my 10 divided by 2 is 5. 2 divided by 2 is 1. The other thing I heard you say, you could do these 2 by 7. So let's do that. 49 divided by 7 is 7. 77 divided by 7 is 11. Let's see.
And then you can do 3 and 15.
Yep. We'll do these 2 here. Those are both divisible by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Here's what I got now. And now when I look again, I still see more. I could put these 5s together. They're the same number, so they're both divisible by 5. They'll just cancel each other out. Here's what I'm left with. I got you, Ashley. Thank you for letting me know. Okay, so here we are. That's as much as we can do. So now we're forced to go straight across now, but it's easy from here. 7 times 1 times 1 is just 7. 1 times 1 times 11 is 11. And that's it. So let me say it one more time with questions like this. If you didn't see everything that we saw here, if you didn't catch like one of them, maybe you didn't see the 49 and the 77 have the 7 in common, and you got everything else, you'll still make your work easier. You'll have to simplify a little bit when you're done, but not as much as you would have if you had gone straight across right from the bat. So that's the whole idea. It's just to make your work easier as you're going through it. You don't have to worry about catching everything. Just make sure when you're done that it doesn't go down any further. Any questions? Let's move on and talk about dividing then. And that'll wrap it up.
Yeah, this is the weird part.
Well, if you can multiply,
I remember defining fractions. It turns into a whole different thing.
It's not too bad. I think once I remind you, you'll be all right. So here's what it says.
Go ahead.
Oh, go ahead.
No, I was gonna say because it starts off with division, but it winds up as multiplication.
Yeah, exactly. So when you're dividing, this is what it says. You divide means to multiply by the reciprocal. So let's talk about that real quick. The reciprocal is a fraction that gets flipped upside down to create a product of 1. So for example, if I started with 2/5 and I flip this upside down, it would be 5/2, 5/2. And if I multiplied this together, it'd be 10/10, which is 1. That's it. That's what a reciprocal is. So if you start with this, you flip. That's it. Just flip the fraction. If you start with a whole number, for example, like this, 8, to make a reciprocal out of this, put your whole number over 1, and that way you can flip it. So this reciprocal for 8 would just be 1/8. The only thing that you got to watch out for is 0. 0, if you put that over 1, that's still 0, that's fine. But if you try to flip this, now the 0 is in the denominator and this is undefined. This is no good. So 0 has no reciprocal. And that's the only one. Everything else could be flipped upside down in some way. All right, so let's go through the steps for dividing. Now that we know what that is, I'm going to put the problem here and we'll go through the steps with the problem. Here's the first one on the notes page. Looks like that. All right, so steps to begin are the same as multiplying. You're still going to convert mixed numbers if you have them. Convert your mixed numbers to improper fractions first. We don't have any mixed numbers in this problem, so I'm going to skip that step for now. Second step is we're going to set this up now so that we can get it started. That means you keep the first fraction. Whatever this is, whether it's proper or improper, you keep it the same. You flip the second one. So in this case, the 2/27 is going to stay. And this second one here is going to flip. keep, flip, and the division then changes to multiplication. So this is going to now be multiplication. Now that you've set this all up, now we can go back to the multiplying rules that we were talking about before. So you have the option, you either take it straight across and then simplify, or simplify and take it straight across. I see stuff that simplifies, so just for the practice sake of it, I'm going to try that again. For example, the 2 and the 8, those are both divisible by 2. Two divided by 2 is 1. And 8 divided by 2 is 4. And then on the other cross, the other diagonal,
3.
3. Good. 27 divided by 3 is 9. And 15 divided by 3 is 5. Take another look at this. I don't see anything else I can do. So I'm going to go straight across. So 1 times 5 is 5. And 9 times 4 is 36. And that's it. So if you can multiply, you can divide. You just have to take an extra step and set it up, and then continue on. All right, let's talk about one more for today, and it is a bit longer, and on the paper it also has negatives. So I'm going to bring that back in just to review. Oops, let me fix that.
Oh, yeah, that
Makes a big difference. All right, so here we go. First of all, when I look at this, this looks like a mess. I've got a negative divided by a negative divided by a negative, another negative. I've got fractions. I'm dividing. There's going to be a lot going on here. So here's what I want to do first. I want to pick this apart piece by piece and eat this bite by bite instead of trying to eat the entire hamburger all in one thing. Let's knock out the negatives. We got enough to deal with. We don't need to be dealing with negatives throughout this whole entire problem. So let's take care of them. Since we're dividing, you got to go back to the rules for division. 2 at a time, which is a negative divided by a negative. How much would that be? This one divided by this one. Anyone?
What, you asked a question?
Yeah.
It'd make it positive.
It'd be positive. So those two are gonna, these two are gonna be positive, and then this together here divided by another negative. What's this final answer going to be once we're all done? Positive divided by a negative.
It's going to be negative.
Okay, so what I'm going to do is figure all that out and put it in front, and then I'm going to ignore it all for the rest of the problem. So I'm going to take it out. I know my answer will be negative based on the integer rules. I'm going to put it in my answer and then ignore it. Is everybody with me? Okay, good. All right, next, I'm going to deal with the fractions. So any mixed numbers that I have, which I have 2 here, one here, I'm going to change them first. Let's deal with that. So 7 over 12 is proper. Just leave that alone. 2 1/3 needs to change. 3 times 2 is 6, plus 1 is 7 over 3. And then the next one, same thing. 7 times 1 is 7, plus 1 is 8.
8 over 7.
Yep. So, got all that done. Next, I'm going to go to step 2, and I keep the first fraction, flip the second, also anything after that, and all my division will change to multiplication. So let's see what that will look like. 7/12 is going to stay. Keep, flip, flip.
3 over 2.
Then multiply and multiply. Scoot that over. Put that down. All right. So I took care of the negative. I flipped everything, and now I'm multiplying, and now I'm going to try to see what I can do diagonally. So I see right off the bat, I see 2 7s that I can put together. You can only do it 2 at a time, so you can't involve that other 7 with anything just yet. These are both going to cancel out. So these are just going to be 1s. Let me go.
3 and 2 is 1 and 4.
This is a 1. Oh, you guys can't see that. Okay, hold on. Let's go down here. I can squeeze this down. So 1 over 1 so far. All right. What was that, Aaron?
I said 3 and 12 is 1 and 4.
Yep. These are both divisible by 3. That gives you a 1 here and a 4 here. And that's pretty much it. Let me bring this in. That's all we can do. If you're thinking, if anybody's sitting here thinking that, can you do the 4 with the 8? No, not here, because they're both in the bottom. You need 1 in the top and 1 in the bottom to be able to cancel. So that's it. That's all we can simplify. We have to go straight across now. 1 times 1 times 7. And 4.
You can't flip the 7 and the 8 because you already changed it to multiplication.
Right.
Before you got to that point.
Yeah. Right. Just flip once and then just go. Don't flip anything back at the end. All right, so there's it. 7 over 32 is all we can do. It's fully simplified, and we're done.